Hello and welcome on day 4 of the HMN Network Wheel Reinvention Jam. I'm Martin Fouillol and I'm programming a live coding audio environment. Yesterday we implemented the hot code reloading feature, which allows us to reload user provided DSP code. And today I think we'll try to make sure that we can have user data that persists across reloads. It's getting warm and sunny here, which is nice, but I can barely see my screen, so let's move inside first. Alright, so I created a file that will contain the API that the application exposes to user code, and that API for now consists in 3 functions. One function to get some persistent block of memory. It takes a size, an identifier, and it returns a pointer to the memory and a boolean that tells us if the block is newly allocated or if it was allocated earlier. We can also clear our persistent memory, for instance, if we modified our data layout and we want to reset everything. And we have that getScratchMemory function that gets us some temporary memory that will get cleared at the end of the DSP function. Here is how it works. We have that persistent entry structure that can get part of a linked list, and it has a hash, an identifier, and a pointer to the allocated memory. In my application structure, I have a hash map of these entries, which is just an array of lists. And I also added a persistent memory arena. Okay, so now here is the implementation of the persistent memory arena. We hash the identifier string, we get the index in the hash map from the hash, we get the bucket from the hash map, and then we traverse all entries in that bucket, and if we find a match, we just return that block of memory. If we didn't find a match, we create a persistent entry in the persistent arena. We set its identifier, its hash, and we allocate a new block of memory from the persistent arena. We append that entry to the bucket, and we return the memory. To clear the persistent memory, we just clear the persistent arena, and we reinitialize all buckets in the hash map. And then the scratch memory is just allocating from DSP arena, which gets cleared at the end of the DSP function. Okay, so now here is an application of the persistent memory API. In my DSP process function, you may remember from yesterday that we used a static float variable for the time, and it was a problem because every time we got reloaded, that value got reset to 0. And it meant that the phase of these two oscillators got reset to 0, and you could hear a click. So now we are using float pointers here, p time, and every time the DSP is reloaded, p time will get set to 0. Here, if p time is 0, we ask for a persistent block of memory that we call time counter, and the first time it will get us a new block, and the next time we will get the old block that stores the value of the time. So there is no interruption in the time, and so we don't hear a click when we reload the DSP code. Now we can run our application, and I can rebuild the DSP and reload, and you see that it gets reloaded and we don't hear a click and there is no time interruption. The basic example of how to use persistent memory. There are many more interesting uses of that kind of memory, and we will see that later. But for now, I think it's good time for a lunch break. Hey, we are back after the lunch break, and I decided I wanted to start working on the user GUI. So the application will expose a GUI API to let the user add widgets to the application window and use them to control their DSP parameters. For now, I just re-export the GUI system of my platform layer. We will see later if we want to wrap it in a nicer and more convenient way. But for now, here how it goes. I added GUI procedure pointer here in my user info structure, and I load that GUI procedure from the user module here. Here I load the DSP procedure, and here I load the GUI procedure. And then in my GUI function, I create a window and I call the GUI procedure here. So in the user module, we still have our DSP procedure, and we added a GUI procedure here. And now I'm just creating a simple button, and I will use it to trigger an envelope and the amplitude of the ring modulation. So here we have our sine wave, which is not modulated, and if I click the button, I trigger ring modulation. I trigger the envelope on the ring modulation. I am freezing. So I played a little bit with sliders, and we can see here sliders to set up the frequency of the oscillators in a continuous way, and I can also click on the button to trigger the ring modulation, and I can change the frequency of the modulator. Nice. And if I want, I can also change my GUI while we are running. For example, see. And reload. And we see the GUI has changed without interrupting the audio. So that's fine and dandy. Let's take a look at the code. So since we are changing the frequency, we can't compute the sine wave the same way we did before, because before I just computed sine of 2 times pi times the frequency times the time, and if I do that while changing the frequency, I will get a non-continuous signal. So what I'm doing now is that instead of a time, I store a phase value for each oscillator, and then I advance the phase by 2 pi times the reduced frequency of the oscillator. So that guarantees us to have a continuous signal. I'm also doing a smoothing ramp on the oscillator frequencies. So I have the frequency of the oscillator and I have a target frequency. Now, what are we going to do next? I think there are several possibilities. By playing around with the DSP process and adding stuff to it and adding more control, we are starting to see that we will want some basic building blocks. For example, we will probably want a basic building block for smoothing values like that, and a basic building block for triggering envelopes, and perhaps some simple oscillators. So we could work on that. On the other hand, there is something annoying with the GUI right now, which is that I don't have any kind of automatic layout. And I have to do all that silly computation here where I have hard-coded rectangles that don't resize properly. And it's just a little bit annoying. My problem with automatic layout engines is that they are either not flexible enough or overly complex. And on the other hand, since it is an application for prototyping, I don't think we need some really fancy layout engine. We probably just want to stack widgets in a nice way, just to avoid doing that tedious work. So maybe we could work on that. We could also have some nicer wrappers around my platform layer functions for GUI. For example, we don't really need to pass the GUI context into each call, since we are always drawing into the same window and into the same view. We could have that in implicitly. We could also have something to automatically remap values to avoid doing that mapping here and the inverse mapping here. I don't really know what I want to do now. I will have to think about it. Well, that's all for today. We implemented persistent memory and we had a first step at adding a user GUI API. After giving it a bit of thought, I think I will go for a simple GUI layout system and a nice widget wrapper. The reasoning behind this is that the GUI is more like a core feature of the program, and the DSP helpers are more like extensions that can be added later on. I also think that having a that simple way to drop some widgets into the application can improve our iteration time and can help us discover more quickly what we really need in terms of DSP features. So that's my thought anyway. Let me know what you think in the Handmade Network Discord, and see you tomorrow.